So you've got these solutions that you can look at, but let me talk through these problems. So again, if it says converge or diverge, you're looking for an infinity or negative infinity in the limits of integration. This one has infinity. So the very first step you must write is the limit as t goes to infinity and replace the infinity with the t. And I'm just going to pull this 3/5 off to the side and rewrite this as x to the -2, just so that I'm ready to take the antiderivative in the next step. So you must carry this limit every step. So then I'm going to carry the 3/5 along, take the antiderivative, so I get -1 over x, and then 2 to t. So now this is an important step that you want to take the time to plug the t in, right? You know, when you have a definite integral, you plug that number in first. So -3/5 1 over t, subtract a -3/5 1 over 2. So now when you plug in the infinity, this goes to 0, and so I get 3/10. Okay, since this equals a number, we can say that this integral converges. So let's do this one. So again, the very first step you must write is that the limit as t goes to -infinity, and put the t down here, and then take the time to rewrite this down here, or this x back into x that's in the denominator. 4x to the -1/3 dx. Okay, so then we're going to take the antiderivative, keep the t's out here. So carry the 4, add 1 to the exponent. So that gives me x to the 2/3 times the 3/2. Again, between t and -1. So now I'm going to take the time to put the -1 in. So if I do a little canceling, I end up getting a 6 times -1 to the 2/3, subtract 6 times t to the 2/3. Okay, oops, my limit got really messy here. So let me rewrite that, -infinity. Okay, so now I'm putting in t is -infinity inside here. So I square the -infinity, that's positive infinity. Take the cube root, that's positive infinity. Oh, look at that. It's all going to be an infinity. I'm sorry, a negative infinity. So that means it diverges. When it doesn't equal, when an improper integral does not equal a number, it diverges. All right, so now what to do? How do you even start these guys? So since it's a cube root, right, you cannot use trig substitution, right? Trig substitution is when you let, x equal sine theta or something like that. So this is not going to work. And so then I would start by thinking, let's do tricky u. And the principle with tricky u is let u equal more than you usually do. So I'm going to let u equal the whole denominator. And again, a principle with tricky u is you want to kind of sort of solve for the x before you take the derivative. Okay, so I'm going to say u cubed minus 4 equals x to the 4th. Now I'm going to take the derivative. Do not make fraction exponents. Whoops. Oh, come back. Make fraction exponents when you're doing this tricky u. So don't take to the 1/4 of both sides. Stop here and take the derivative. So 3 squared du equals 4x to the 3rd dx. So I'm going to make this u substitution work. So the denominator is u, right? Okay, so that's going to be taken care of. The dx, I need to take out the dx. Well, the dx is connected with an x cubed. So I need to rewrite this. Whoops, I lost the du there. Du equal x cubed dx. So I can take out dx as long as there's an x cubed to take it out with. Wait a minute, I think there is, right? So let's rewrite this as x to the 4th times x cubed dx, and then I've got this whole thing in the denominator. Okay, so let me make this smaller. So I see that I can take out x cubed dx and put in 3/4 u squared du, right? That's a substitution. So then the denominator I can see is just u. All right, now what am I going to do with this x to the fourth? X to the fourth, do you see it? It's right there. U cubed minus 4. Put the parens in so you make sure you see them. All right, I'm going to take my time. I'm going to pull this number 3/4 outside. And I'm just going to take one more step just so I don't make a mistake. That's all over u, and that's times a u squared. Hey, look at that. I think these u's cancel, don't they? So I'm just going to move down here. So I get 3/4, and then u cancels. So I get u cubed minus 4 times a u du. Taking a lot of room here, but I want to make sure I do it right. So I want to make sure I multiply this in first, right? Minus 4u du. Okay, now let's finally take the integral. U to the 5th over 5 minus 4u squared over 2 plus a c. Okay, so then what do? I need to erase so I can put it all back up here to know what to plug in. Because you have to keep this initial u substitution nice and clear so you know what to plug back in, right? Okay, so I want to have 3/4, and then I'm going to have a 1/5, and then u to the 5th power. So my u is this, right? So I'm going to say x to the 4th plus 4, and that's 5/3 power, because it's the u to the 5th power, and the u is to the 1/3. All right, so then the second term here, I'll just simplify it to get a 2. And then the u, which would be x to the 4th plus 4, all to the 2/3 power plus a c. All right, that was kind of challenging.